Hey everyone, welcome back to IBDP MAA HL SL course. Today we are going to talk about topic 1 number and algebra, subtopic 1.3 geometric progression or geometric sequences. So these are the subtopics that we are going to cover today, like geometric sequences and series, the use of general term formula and the sum of n terms formula, then sigma notation, and also some applications of the geometric progression in spread of disease, salary increase, decrease, or population growth related problems. Okay. So let's get started with the meaning of the geometric progression. As you are already familiar with geometric sequences, those sequences in which we have to multiply by a fixed number to get the next term, right? So for example, we have, let's say, starting with 2, 1, okay, 1, 2, 4, 8, 16, right? What you are doing? You are simply multiplying by 2 to get the next term. So here we have the first term, let's say A1 is 1 and the common ratio this time is 2. In order to get the common ratio, what you can do is you can always divide this A2 by A1 or A3 by A2 or A4 by A3 or anything like this. Always you will get the same answer, that is your common ratio. In that case only the sequence is in GP. If you are not getting the same ratio, then it is not geometric sequence. Okay. Now, if A is the first term, then next term will be what? AR, because R is the common ratio. In order to get the next term, we have to multiply this. This is A1. In order to get the next term, we have to multiply AR with R again. So AR times R gives AR squared. That is the third term. What is the fourth term? AR power 3 to get the fourth term. So can you tell me what will be the 20th term here? 20th term. So for the second term, we have r to the power 1. Third term, r to the power 2. Fourth term, r to the power 3. So 20th term will have a times r raised to the power 19. One less, right? So in this way, we can say the general term or any nth term will be a times r raised to the power 1 less n minus 1, right? So in this way, we can determine the general term of the geometric sequence. Okay, so this is the formula. From now onwards, we can directly use this formula for finding the general term. Similarly, we also have a formula for the sum of first n terms, and formula is also provided to you in your formula booklet. So both are same. Sn equals to a1 times 1 minus r raised to the power n minus 1 n upon 1 minus r, or Sn is equals to a1 times r to the power n minus 1 upon r minus 1. Both are same. If you take minus sign common from the first one, you will get the same second. Okay, so let us solve some questions on geometric sequences. Here it says for each of the sequences we have to find the first term as well as the common ratio r. So let's start with the first one. Here we have 5, 10, 20, 40. So what is that? First term is 5. What is the common ratio? What is the number with which we multiply this one to get 10? Number is 2, right? So common ratio is 2 and the first term is simply 5. Now, in order to get the common ratio and the first term of the second, okay, first term is 24. What is that number by which if I multiply 24, I will get 12. So you can find 12 by 24. What is that? Half answer. So in this way, simply, if the sequence is given to you, you can find the common ratio if the sequence is in GP. Next, application based. A space probe in a protective pod is released from a spacecraft and falls to the surface of the planet 20 meters below. Okay. On impact with the surface of the planet, the pod bounces upward. Engineers estimate that the pod will bounce 65% of its previous height. Okay, after every bounce. So, if the probe falls from this height, okay, this height is what? 20 meters. Now it bounces back, goes up to what? 65% of that 20. So what is that? 20 times 0.65, right? And then comes back, travels the same 20 times 0.65 distance, bounces back again. So what will be the height in this time? Right? This is the first bounce. After second bounce, the height will be what? 20 times 0.65, this was the original previous basically, multiplied by again 65% means 0.65. So this is what 20 times 0.65 squared. So can you see 20 times 0.65, 20 times 0.65 squared. In the same way we can get the height for the third bounce also, right? Now, it says find to the nearest meter the total distance traveled by the pod at the moment for the fourth impact. Okay, so let's first understand the situation. What happens is, I'll draw a diagram over here. First is it covers the 20 unit distance, right? From the top to this. It is not going back to 20. No, it is going, it after its first bounce, it is this distance which is 65% of the 20. Okay, so now it says total distance means I need to add up this distance traveled by the pod at the moment of the fourth impact. At the moment only means not on the fourth bounce. Okay, not after the fourth bounce, on that point. So here up to this, because here is the that space probe will take its fourth bounce. We don't need that. Okay, so in this way we can say the heights after first bounce is 20 times 0.65. Height after second bounce is 20 times 6.65 squared. After third bounce, 20 times 0.65 cube. We needed only these, and the 20 is also. And one more thing, when it goes up, it comes back with the same distance. Here, back, here, back. Right? Okay. So for the first part, we just need to add up all these. Okay, so first 20 units distance, and then twice the distance traveled with first bounce, twice the distance traveled with second bounce, and twice the distance traveled with third bounce. Add up, right? We can simply add them up. You can use your calculator for that. Okay, so we get this value using the sum of n terms of the GP. Here, leave the first term, take 2 common from these terms, so you will get a GP. This is the first term, this is the second term, this is the third term. In order to get the common ratio, you can take A2 by A1. That is your common ratio. So if you use that, common ratio is 0.65. So if you use that, you will get A times, this is A, times 1 minus R raised to the power n, because there are 3 terms, so I will take 0.65 raised to the power 3 divided by this. Have a look at this. Okay, now we can use our calculator to get the value for this, and it says find the distance to the nearest meter. Okay, so when I enter this value in the GDC, I get 73.885, and to the nearest meter it is going to be 74. So 74 is the answer for the first part. Now B part says the physical condition of the probe is measured in safety units. Each one bounce costs the probe 2 safety units, and the probe begins with 112 safety units. If the number of safety units falls below 84, the probe fails. Okay, probe fails if the safety points are less than 84. Now it says if the probe bounces 13 times in total, predict if it fail or not. So what we have to do? We have to find how many points, how many safety units are still there, remain after 13 bounces. If that number is less than 84, probe will fail. If that number is more than 84, it is not going to fail, right? So it starts with what? 112 and reduces by 2 units. So what kind of sequence is this? It is arithmetic sequence because it starts with 112. Next, after first bounce, it's 110. After one more bounce, it is 108, and so on, right? So it starts with first bounce 110, second bounce 108, third bounce 106, right? So we need to find what will be the value after 13 bounces, since it is arithmetic sequence with the first term as 110 and the common difference d as 2. We can directly use the sum of n terms formula. What is that? U1 plus n minus 1 times d. U1 is 110, n is 13, t is minus 2, right? So we can simply simplify this for 13th term, which comes out as 86. 86 is more than 84. Rob is not going to fail. Okay, answer. Next part. It says evaluate this sigma from 1 to 10 for 2 times 5 raised to the power r. So here later you can use the calculator to find its exact value. Okay, but let me tell you what it means. This sigma representation means that added up terms gets added up starting with r equals to 1. So you have to take r from 1 up to 10. So take r is equal to 1. What is that? 2 times 5 raised to the power 1. This is your first term. After doing that, take a plus sign because of this sigma. Then put r as 2. So 2 times 5 squared. Second term plus 2 times 5 raised to the power 3. That is the representation. Okay. So in this way you have to do it for 2 times 5 raised to the power 10. So there are total 10 terms. What kind of sequence is this? If you observe, here we are multiplying by 5 to get the next term. Here the first term is 2 times 5, which is 10, and the common difference ratio r is simply 5, right? Now we have to find the sum of first 10 terms. We can use the sum of n terms formula for the GP. Okay, so you can use a times a is what? 10. 10 times r raised to the power total number of terms means 5 to the power 10 minus 1 divided by 5 minus 1. Okay, so if calculator is not allowed, then you can leave your answer with this. 5 minus 1 gives 4, 10 by 4 gives 5 by 2 times 5 raised to the power 10 minus 1. If the calculator is not allowed, you can leave your answer here because it is a very large number, right? If the calculator is allowed, then you can find its value in your calculator in the standard form basically. It is coming out as this 2.44141 something times 10 raised to the power 7 in the standard form. Okay, that was sigma representation. Next, if the sum of infinitely many terms is to be calculated for the geometric progression. What is that? See, if we have 2, okay, plus 4, plus 8, plus 16, plus 32. If I add infinitely many terms of this sequence, what will be that? It is going to be a very large number. It is tending towards infinity because it keeps increasing. It keeps increasing. So it is divergent. So you cannot calculate the sum of infinite terms in this case. But can we calculate, is there any condition under which we can calculate the sum of infinite terms? Yes. The thing is, it is related to its common ratio. Okay. See, if the common ratio is lying between magnitude value, basically, if the magnitude value of the common ratio lies between 0 to 1, when you multiply by that number, the magnitude value of the next number is smaller than the previous. Smaller, smaller, smaller. Basically, the nth term or infiniteth term will tend towards 0. Okay. So in this way, yes, there is a possibility to get the convergent sum. Okay. So here, if you have something like this, and if you have a number lying between 0 to 1, keep increasing its power. Take 0.5. What is that? 0.5. 0.5 squared. 0.25. It is smaller than previous. 0.5 cube. 0.125 smaller than previous. 0.5 power 4. 0.0625 smaller. So if you see the number is moving closer and closer towards 0. So if I take 0.5 raised to the power 10,000, it will be a very small number. It is going to be a very small number, almost 0. Right? So if we have infinitely many terms, it means we are having 0.5 raised to the power infinity. That is almost 0 again. Okay, so that's the only reason that sum will be convergent if the common ratio magnitude lies between 0 to 1. Magnitude, I said. Okay. Then only you can find the sum of infinite terms, otherwise not. This is the condition. Okay, so for example, we have to find the sum of infinite terms. What is the formula for that? We have already seen the formula for sum of n terms is Sn is equal to u1 times r raised to the power n minus 1 upon r minus 1, or u1 is times 1 minus r to the power n divided by 1 minus r. Now, as I said, my common ratio magnitude value is lying between 0 to 1, right? So if it is the case and limit n tends to infinity, means if I take infinitely many terms, then what happens is this r raised to the power n will become 0 in that case. So sum of infinite terms will be, I'll use this one, u1 times 1 minus 0 divided by 1 minus r, which is simply u1 divided by 1 minus r. So whenever you have to find the sum of infinite terms of a GP, but the condition is its common ratio magnitude value lies between 0 to 1, you can directly use this one. Okay, that's it. Okay, now next is, let's solve a question on this. Find the sum of infinitely many terms of the geometric series. 45, next is minus 15, 5, minus 5 by 3, 5 by 9, and so on. Infinitely many terms are there. So let's check whether the common ratio is lying between 0 to 1 or not with the magnitude value. Okay, so for that, let's find that value. We have first term as 45, and the common ratio which can be obtained by a2 by a1 means minus 15 upon 45 comes out as minus 1/3. Okay, minus 1 by 3 is the value of the common ratio in this case, right? Okay, so we have the first term. We can directly use the formula for the sum of infinitely many terms, which is S infinity is equals to a upon 1 minus r, and on simplifying it, 45 upon 1 minus of minus 1 by 3 comes out as 135 by 4, and you can see, yes, we are getting a finite answer. It is convergent. We call it convergent. If it tends towards infinity or minus infinity, that is divergent. Okay. So in this session, we have covered some questions on general term related problems. Yes, right. Then the use formula to determine the number of terms in the geometric series done. Simultaneous equation to find the first term and common ratio. We did this in the last session for the AP already. So sum of n terms related problems, sigma notation done, geometric sequences from the description, and evaluating the expression using the sigma notation. All parts are done. Okay. So I hope you get all this, and if you still have anything to ask, feel free to connect with me. Okay. So you can also contact me for any regular session or one-to-one tutoring on this number using WhatsApp or Telegram, or you can also mention your query in the comment box or in the chat box of this video. Thank you for watching this. See you in the next part. Keep watching, keep learning.